Welcome, ladies and gentlemen, to the webinar with a focus on the new test method for open equipment. I'm participating from Dresden, Germany for the test lab Fraunhofer IVV, and I will represent the method on behalf of all three test laboratories. And thank you for allowing me to give you a more detailed insight into the new test method. In the next few slides, I will present you the single steps which are necessary for the testing of test object. And yeah, for the testing, in summary, there are 4 different steps necessary. The first step is the preparation of the test object. After that, a soiling process is necessary to get a defined and reproducible coating on the test object. And the third step is the cleanability test itself. And finally, we check the test object if there are any residuals and assess the cleanliness. And for the test, we additionally use a reference part, which has a hygienic design side and a non-hygienic design side. It's a quite complex part, as you can see in this image, and it has different geometries and design features, for example, clans, holes, and seals. And we mainly use this reference part for the verification of the function of all single steps in the test procedure. And it has to be figured out that the reference part is not a comparative object for the evaluation cleanability. And all steps that are carried out with the test object are also carried out in parallel, respectively, directly afterwards with the reference part. And we come to the first step, the preparation of the test object. As a test object, we can currently use a maximum size of around about 800 by 800 and multiplied by 400 millimeters. And the size is primarily limited by the use of an industrial robot for the cleaning process. However, it is also only a reference value and can lead to deviating data depending on the shape of the test object or the use of other cleaning robots for testing. And the first step is an initial cleaning at an associated test laboratory. And so we get equal starting conditions for the test object. And here, a complete dismantling of all removable parts is necessary, and we inspect all parts for absence of damages and damaged gaskets. And after the inspection, we clean all parts with ethanol, rinse them with deionized water, and dry them with clean air. And then we check all surfaces for residual soils, and if it's okay, we reassemble all parts to the assembly again. And the final step for the preparation is the conditioning in a climate chamber for around about 18 hours. And so we have prepared the test object. There are no damages, there are no residuals on the test object, and we have comparable start conditions for every cleaning test. Now we come to the next step. This is the soiling procedure. Here it is important that we have reproducible test soils and comparable coating on the test object. Therefore, 4 steps are necessary: the production of the test soil, the mounting of the test object, the soil application on the test object, and drying again. As test soil, we use condensed milk mixed with UV tracer to get a better optical signal. And in step one, we dissolute the UV tracer in the milk with a magnetic steering rod for around about 10 minutes. And so we get a good distribution of the tracer in the milk. And after that, we mix this solution with more condensed milk in a laboratory stirrer using a special paddle for around about 20 minutes. Now we mount the test part in the correct position. It is important that for soiling and cleaning, the same position is used. For the positioning, there are different options. Option one is if there is an instruction or installation instruction available, this position would be used also for the cleaning. If, on the other hand, the installation instruction contains a prohibited position, the nearest permitted position is used. Here an AEO defines this position. And the third option includes the worst case position if there is no special installation instruction available. And here also an AEO defines this position. Depending on the size and the design of the test object, different types of fixing elements are used, and we have to mention that the contact surface with the fixing elements are not taken into account during the evaluation. And now we come to the next step. This is the soiling, which is done in a controlled environment. And the test object is soiled by a spray bottle until the complete surface is covered with the test soil. And also automated soiling procedure is possible. And if there are any movable parts, special steps are necessary. After supersaturation, the moving part is moved 10 times. Then it is returned to the cleaning position, and supersaturation is performed for a second time. And now we control all surfaces of incomplete coverage to avoid spray shutters, for example. And after that, drying is required under normal condition for 18 hours. And it is important that there's no change in position between the soiling process, drying process, and the cleaning process.